friends, last class we had a brief introduction about laser. Today we will be discussing about different laser characteristics because of which laser is becoming so much important nowadays. Okay? So why this laser is of so much interest? What make it so special? This is because laser has some unique properties and those properties we will be discussing under this laser characteristics. The significant characteristics of laser beam are highly directional, collimated, negligible divergence, high coherence, highly monochromatic, and high intensity and power. So these are some of the significant characteristics of laser because of which laser is of so much importance nowadays. We'll discuss one by one. First, we'll look into what is highly directional. Here you can see this is a conventional source of light, that is a bulb. Here the light is emitted by the bulb in many directions. Okay, you can see over here in all these directions we are getting light from this bulb. Similarly, if you consider a candle or sun, we are getting lights in different directions. So in a ordinary light such as light from the sun, a light bulb or a candle, the light is emitted in many directions. Now coming to laser, here you can see the light is going in a particular direction. In this direction you are not getting any light. Only in a single direction you are getting light. So the light is highly directional. That means almost all the light emitted by the laser is going in a particular direction. So laser emits narrow beam of light that is highly directional, that is in a specific direction. Coming to the next property, the light emitted by laser is highly collimated. What is the meaning of this collimated? A beam of light or any other electromagnetic radiation is said to be highly collimated if it consists of parallel rays and hence the spread is minimum as it propagates. In a beam of light we are having number of rays, right? If all those rays are parallel to each other, then that is known as collimated beam of light. And further in this case, the spread is minimum. Let us understand this. Here this is a conventional source of light. Here you can see all the light rays, they are going in different directions. They are not parallel to each other, they are crossing each other at some or other point. So this is an example of uncollimated light. And coming to spread, if we will take the two extreme rays, this is the extreme one, this will go this way with respect to time and this will extend this way with respect to time. So the spread is minimum here and it is increasing as the light propagates, right? So the extent is increasing, right? Or the spread is increasing as the light propagates. Thus, the ordinary light is an example of non-collimated source of light. Coming to laser, these are the laser rays or the rays in the laser beam. Here you can see all the rays are parallel to each other. Now coming to spread, if we will extend the extreme one, this one will go this way with respect to time and this one will move this way. Okay. So here you can see there is the spread is minimum. That means the distance between the two extreme points is almost constant. Okay. So this is the example of laser which is a collimated source of light. Now coming to the third property, that is negligible divergence. This comes from the previous one. There also you have seen this is for an ordinary light which is a source of uncollimated light. Here the spread is maximum, okay, And spread is maximum means as the light beam propagates, the rays are moving more and more from each other. They are diverging from each other. That means the divergence is more in the case of ordinary light. So in case of ordinary light, the divergence is very high. Now coming to laser, here you can see the divergence is negligible, because when this propagates, we can see that they are moving parallel to each other, so that their separation is minimum, and hence the divergence is also minimum. There is negligible divergence. The next one is high coherence. What is the meaning of this coherence? A coherent source of light emits light waves having same frequency, wavelength and phase. Thus, a source of light is said to be coherent if the light emitted consists of waves those are having same frequency, same wavelength and phase. Let us understand this with an example. Here you can see this is in case of ordinary light. Here I have considered few light waves, and if you will see, here the frequency is different from this one. Further, the frequency is different for each and every light waves. Coming to wavelength, here the wavelength is from this to this. So this is the wavelength for the first wave. Coming to the second one, it is larger as compared to the first one. And here it is shorter as compared to the above two, right? This is in between. Similarly, this one is also having some different wavelength. So the wavelengths are different for all the light waves consisting the light beam. Now coming to laser source, these are the light waves in the beam. Here you can see all are having, at this point if you check the phase, all are having the same phase. But here at a single point if you check, all waves are having different phase. So here the phase is also same. Coming to the wavelength, this is the wavelength which is same for each and every wave, right? Similarly, the frequency is also same. Hence, the light which we are obtaining from a laser source, that is highly coherent. So the ordinary light is an example of incoherent light source, whereas laser is a coherent light source. The next property is highly monochromatic. A light is said to be monochromatic if it contains a single color or single wavelength. All of you must have used a prism to get the dispersion pattern of white light. So if we are incidenting white light on a prism, that will disperse into 7 component colors starting from red to violet. That means this white light is consisting of 7 colors, because from this white light only we are getting all these colors. That means the white light consists of lights with different wavelengths. So the ordinary light is a mixture of different wavelengths. Contrary to this, in case of laser, here this is a red laser, it is emitting only red color light. That means the wavelength of the light which is coming from this is only a single wavelength. Similarly, this one is a green laser which emits green color. This is a blue laser which emits blue color. Only a single color light is coming from different lasers, and hence they are consisting of light of single wavelength, right? Thus, these laser sources are highly monochromatic as they are consisting or emitting lights of single wavelength or single color. Further, the intensity of laser light is very high and the power is also high. What is the meaning of intensity? Intensity of light is the amount of light energy per unit time flowing through a unit normal area. Consider the case of a bulb, there light is emitted in all possible direction. So if I will consider the light per unit time flowing through a particular area which is perpendicular to this source, we will be getting only this much light, right? All these are not coming through that. So it is coming only through this unit normal area. So I am getting only this much light. That means the intensity is less, though it is emitting in all possible direction. While we are considering the intensity, we have to consider a unit normal area, and we have to find out the light passing per or the light flowing per unit time. So in case of ordinary light source, the light spreads out uniformly in all directions. So if we'll consider a particular direction, we'll be getting less intensity, right? Because it is getting distributed in all possible directions. In case of laser, the light spreads in small region of space and in a small wavelength range. In case of laser, we have seen the spread is minimum, and hence the light is passing through a small region which is perpendicular to the laser source, and hence we are getting a high intensity. Thus, laser light has greater intensity and power as compared to ordinary light. Because of this high intensity, we are using laser to cut many strong materials, wood, etc. Okay. So these are the properties of laser. In the next video, I will be discussing why we are getting such nice properties in case of a laser. So today we'll stop here. Thank you for your listening. If you like the content of the video, please press the like button and share the link with your friends. Also, do subscribe to my channel to get the notifications whenever I am uploading a new video. Thank you all.